We're going over the Chapter 7 review. This is Part 2. Question number 8 is where we're at. It says solve the quadratic 2x squared plus 7x minus 15 equals 0 by factoring and show your work. If we're going to solve by factoring, what do we need to know first? We need to know the a, b, and c. So the a of the quadratic is 2, the b of the quadratic is 7, and the c of the quadratic is negative 15, because standard form of a quadratic is ax squared plus c equals 0. Now when we're looking for the solutions to the quadratic, what are we really looking for? The values of x, right, that make y equal 0, which are the x-intercepts. And so we call the solutions to a quadratic solutions, first of all, and then zeros because they're the x's that make y equal 0. Graphically speaking, if it dips below the x-axis, then those are the values of x when y equals 0. And so graphically speaking, they are the x-intercepts. And when you get rid of a square, what do you have to do? Take the square root, so we also call those the roots of the quadratic. So they're called the solutions to the quadratic, the zeros of the quadratic, the x-intercepts of the quadratic, or the roots of the quadratic. We're solving by factoring. It has an a, b, and c, so we factor using the blank method, the AC method of factoring. Good. So we take our a, which is 2, times our c, which is negative 15, and we get negative 30. We always focus on the signs, and so we realize that the sign of the 30 is negative, which means that the factors that I'm fixing to try to find need to be different signs. So I need different sign factors, and that's important to write down, I believe, because it helps us get all of our sign rule sentence right in a minute. We have to get a proper sign rule sentence, or we'll make mistakes in factoring. Okay, so step 1 said find AC, which we've done, and then we analyzed all the sign stuff up to there. Step 2 says what? Find all the factors of AC. So we want all the factors of negative 30, only we're really just going to look at positive 30, right? And so we say 1 will go into 30 30 times, and 2 will go into 30 15 times, and 3 will go into 30 10 times, and 4 does not divide evenly, so we leave it off. And 5 will go into 36 times, and we kind of wrapped around because of 5 and 6 hit. The next thing would be 6 times 5. We don't double up. And so that's all the factor pairs of 30. That's step 2. Step 3 says to do what? Pick the pair that add to give you B using sign rules. So we think about the sign. The sign of the B is positive. So we've got it all set up for our sign rule run. We're going to say one of the 4 sign rules on page 18 exactly word for word. And so here it is. When you add or subtract with different signs, you subtract and take the larger sign, which needs to be positive. There you go. When you add or subtract with different signs, you subtract and take the larger sign, which needs to be positive. So my factors need to be different signs with the larger positive. So I make my largers positive, Therefore, my smallers are negative. So that little drill told us to put negatives on those. Everybody understand that? We're still on number 3. We just said the sign rule that's associated with this particular problem. And so we want to pick the pair that add to give us our b of positive 7 using sign rules. Now, when you add with different signs, we're going to subtract. So we're really going to subtract them because of sign rules, right? So which ones of those have a difference of positive 7? Negative 3 plus 10. So that's the pair that add to give us 7 using sign rules. When you add or subtract with different signs, subtract and take the larger sign. 10 minus 3 is 7. The larger is positive, positive 7. So we found the pair that give us b using sign rules. That was step 3. Step 4 says split the middle term into those two pieces. We're quoting page 213, right? Step 1, 2, 3, 4, 5, 6. We're going to split the middle term into negative 3x plus 10x. And we're still going to have the 2x squared. So we make that negative a minus. And we still have a minus 15 is equal to 0. You understand that? Split the middle term into those two pieces. Step 4. Step 5 says factor the left pair in, factor the right pair. We factor out the greatest common factor. The greatest common factor drill's on page 5 and page 213. What's the GCF between 2x squared and 3x? X. If you didn't know that, you would take the 2x squared and write out its factors, which are 2 times x, and then you would take the negative 3x and write out its factors, which are negative 1 times 3 times x. There's only one common factor, x, so that's the GCF. Had there been more than one, we'd have multiplied one of each of the common factors, right? So we're going to pull out an x, and so we think x times what is 2x squared? 2x. And then x times what is negative 3x? Negative 3. Understand that? Now we factor the right pair. What's the GCF between 10x and negative 15? 5. So we can pull out a 5. And so we think 5 times what is 10x? 2x. And then 5 times what is negative 15? Negative 3. Now we should have gotten a common binomial. If at this point you do not get a common binomial, then it will not factor. That or you messed up, one or the other. That was step 5. Step 6 says, write it as two binomials. To write it as two binomials, what do? We take the common one and make it the first binomial. And then how do we get the second binomial? We take the two pieces, x and positive 5, x and positive, so we put a plus 5. We have successfully factored the quadratic, but have we found the solutions to the quadratic? No, there's a paragraph on page 214 at the bottom, rule 3 it is, that says if two things multiply to give you 0, then either the first one or the second one or both of them have to be 0. And then it says the solutions to a quadratic may be found by factoring only after what? You set each factor equal to 0 and solve. The solutions to a quadratic may be found by factoring only after you set each factor equal to 0 and solve. Everybody understand that? So we're going to solve these. So we would add 3 to both sides. We're going to have 2x equal 3. Divide by 2. And we have x is equal to 3 over 2. On the other one, we would subtract 5. And we have x is equal to negative 5. So those are the solutions, roots, zeros, intercepts of the quadratic. How else could we have written those answers besides the way we did? We could have written them as ordered pairs, right? They are the zeros of the quadratic, meaning what? The values of x that make y equal to 0. So we could have written them as ordered pairs, right? Any questions on number 8? Solving a quadratic by factoring. Okay, that was on page 213 and then 214. Very good with number 8. Okay, number 9. Number 9 says solve the quadratic by completing the square. This is not something that I'm going to have on the test for 2007-2008, but I taught it in class. I didn't make you do the homework on this. And so I'm going to go ahead and go over it on the review because I want us to see this. You need it to be able to understand how to go from standard form to graphing form on a quadratic, right? So it's a good exercise for us to know before we leave this class, although it's not tested. So we're talking about completing the square, which is on page what of the book? Y'all may have to help me. What's that? 218, page 218. There you go if you need to look at that for a reference. It says to complete the square, what's the first thing you do? You make a be equal to 1 by dividing by a, but a is already 1. So we don't need to do that step, right? I'm going to move this down. If a was anything besides 1, you would divide through by a. What does it say to do next? I'm going to fix that little deal right there. We're going to move our c to the other side. So we're going to move the 13 to the other side, remembering to change the sign when you cross over. So we're going to have x squared plus 14x is equal to negative 13. The next step says to take 1/2 of b and square it. My b was the 14. And so we're going to take 1/2 of 14 and square it, which is 7 squared, which is 49. And we're going to remember what half of b was because we're going to need that in a minute, right? We're going to take half of b and square it, and we're going to remember that half of b was 7. What do you do with that 49? You take half of b and square it, and you get 49, and then you add it to both sides. What have we just done? We've created a perfect square trinomial. What makes a perfect square trinomial? Here's what makes a perfect square trinomial. To be a perfect square trinomial, a needs to be equal to 1, and c is equal to 1/2 of b squared. If a is 1 and c is half of b squared, then what you have is a perfect square trinomial. So what did we do? We made A be 1, and then we made our C be the half of B square answer. So we created a situation where A is an understood 1 and C is half of B square. So we created a perfect square trinomial. We don't care what the other side looks like. We're just trying to make the left side a perfect square trinomial. What does a perfect square trinomial factor into? It factors into x plus whatever 1/2 of b was quantity square. That's what it factors into. X plus whatever half of b was square. So our directions say to make a 1 by dividing by a, move the c to the other side, find out what half of b squared is and add it to both sides. So what'd you do? You got rid of your old c and you made yourself a new c. The new c is half of b squared, which created a perfect square trinomial. The square root of a perfect square trinomial is x plus whatever half of b was quantity square. X plus whatever half of b was quantity square equal 36. Now, we have created a perfect square trinomial. We learned on that lesson that if we wanted to get this in graphing form, what would you do? Move the 36 back to the left. So graphing form is x plus 7 square minus 36 equals 0. All you do is move the 36 back over and it's in graphing form. But we're not really trying to graph, we're trying to solve. What we've done here is we've gone from two names, x squared and x, in which case you cannot use the order of operations, down to one name x, in which case you can use the order of operations. So by making it a perfect square trinomial, completing the square, and writing it as a binomial square, we go from two names, x squared and x, down to one name x. So now we can use the order of operations to solve. The operations that we have to deal with are parenthesis and exponent. Now we're going to be undoing, so which one do you undo first? Exponent, because we undo in the reverse order, right? Sally Aunt, dear my excuse, please. You undo exponent first. What gets rid of the square? Square root. And in case you've forgotten when you do the square root, you can look at page 26, example 5. You remember you got to do the plus or minus square root of? And so we're going to have x plus 7 is equal to the positive square root of 36, which is 6, or x plus 7 is equal to the negative square root of 36, which is negative 6. Let's see how we got that. And then we solve each one. So we subtract 7. We get x is equal to negative 1, or subtract 7. We get x is equal to negative 13. So those are the solutions, zeros, roots, x-intercepts of the quadratic, which again could have been written as ordered pairs, negative 1, 0, negative 13, 0. Because they are the values of x that would make y equals 0, which are the x-intercepts of the quadratic. The roots are the zeros of the quadratic. Any questions on number 9? Solving a quadratic by completing the square. As you finish writing, I'm going to talk some more. Remember that the definition of a perfect square trinomial is a trinomial such that a is 1 and c is half of b squared. A perfect square trinomial factors into x plus whatever half of b is quantity square. In this situation, A was 1, but my C was not half of 14 square. It was the wrong number. So I moved it to the other side. And then I changed it to a 49. Now you realize if you study that a little, we could have, instead of moving that 13 over, we could have just added 36 to it to make it a 49. And we'd have ended up in the same place. But it's usually easier when you're teaching students to say, get it plumb out of the way and let's make us a new one. It's going to come out the same anyway. But it's got to turn into half a b squared somewhere or another. And then once you create that situation where you have an a of 1 understood and my c value is half of b squared, then this side over here becomes a perfect square trinomial, which factors into x plus half of my b value squared. That's the deal. Any questions on completing the square for a quadratic? Okay? All right, number 10. This takes us to page 223, maybe. Is that a good page in the book? All right, quadratic word problems. Normally in Algebra 1, you don't have to come up with your own formula. You will in physics and in Algebra 2 and pre-calculus and all those where you're getting some applications of this. And here we're just trying to introduce to you how to solve a quadratic. So normally we give you a formula and you plug into it. If profit for a play may be expressed in terms of attendance by the formula P equal 3a squared minus 25a plus 50, then how many people must attend for the play to have a profit of $100? So we're going to take the given formula, P is equal to 3a squared minus 25a plus 50. We're going to make it our equation, and we're going to make the characters of the story the pieces of my formula, profit P, which we know to be 100, and attendance, we don't know, it's been assigned the variable A. So we want the attendance that would create a profit of 100. So we plug what they give us into the given equation, and then we would solve. And I'm going to get the equation written down here and then give you a little bit of catch-up time on your note-taking. Understand to that point? And on page 23, right after that, it says but. And then it says something that we have to call attention to, or you mess up after that, right? We're going to write our own formula, or we're going to use the given formula, but before you solve a quadratic by any method, you must first set it equal to 0. Why do we set it equal to 0? So it'll be in standard form, ax squared plus bx plus c equals 0. You don't have an ABC unless you have a 0. It's not really A, B, and C unless there's a 0, right? So we need to set it equal to 0. Well, what's it equal to now? 100. It needs to be equal to 0, so we're going to subtract 100. I'm going to get that underline out of there so it don't look like a divide. So we're going to subtract 100 from both sides to set it equal to 0. And we're going to have 3a squared minus 25a minus 50 is equal to 100, is equal to 0. That came from this over here, right? There we go. 3a squared minus 25a minus 50 is equal to 0. Now we have a quadratic in standard form. We can solve by graphing, by factoring, by completing the square, or using the quadratic formula. I'm going to use the quadratic formula because it hasn't been used on this review yet, I don't think. Anyway, so the quadratic formula is what? The opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So my a is 3. My b is negative 25. My c is negative 50. Be sure and carry the minus as a sign there. So we're going to plug into our formula. I'm going to start over here so I'll have a little more room. We're going to have x is equal to the opposite of b. So we're talking about the opposite of a negative, which is a positive 25, plus or minus the square root of my b squared. Now b is a negative. When you square a negative, you have to put it in parentheses square. We learned that on page 171, I believe. And then we have minus 4 times my a of 3 times my c of negative 50. That's a times sign, not a, there we go. Times my c of negative 50, and my radicals still going. All over 2 times my a of 3, and that's a minus right there. We'll make it a little bigger. Let's say we got all of that. Now, if we were going to do this in the calculator, we would have to add parentheses. I'm going to do it in green. Where would we add those parentheses if we was going to put it in the calculator? Whole top, entire numerator, entire denominator, and everything under the square root, and we already put them on the negative 25 that was being squared, right? Now, if we do this on paper, what 3 things can we do? First, square that, multiply that, and multiply that, right? And so we're going to get x is equal to, understood open parentheses, 20, excuse me, plus or minus the square root of 25 squared, 625. You're going to have 4 times 3 is 12, times 50 is 600. You're multiplying with an even number of negatives, so the answer is a positive 600. They say we got that? You got to watch those sign rules, they'll get you up. All over my 2 times 3, which was 6. So on paper, what am I going to do next? Add those, right? And so I would have x is equal to 25 plus or minus the square root of 1,225 over 6, right? So now what would I do? Square root of 225, is that 35? Good. So we're going to move this over here. So we're going to have x is equal to 25 plus or minus 35 all over 6. Now, why is there a plus or minus? Because a negative number square is the same as a positive number square. Good. And when you take the square root, then you want that positive and negative answer. So we're not going to do the plus or minus thing until after we take the square root, because that really says plus or minus whatever the square root answer was. So it's not time to do the plus or minus until you get your square root answer, right? That makes sense? Okay, and so we're going to have x is equal to 25 plus 35 over 6, or x is equal to 25 minus, which I chopped off, the 35. Getting kind of crowded here. I'm going to have to move it. Sorry. And so we've got x plus x equal, I'm going to make it, x is equal to 25 plus the 35 over 6, or x equal 25 minus the 35 over 6. And we solve each one, so we're going to do 25 plus 35 is 60. So x is equal to 60 over 6, which is 10. Or x is equal to 25 minus 35 is negative 10 over 6 is negative 5/3. So x is equal to 10, or x is equal to negative 5/3. We're talking about a real life story. How many people must attend? You can't have negative 5/3 attendance. You can't have negative attendance, and you can't have 5/3 of a person, right? Unless somebody's expecting, I guess. But anyway, so the answer that makes sense to the story would be 10 in attendance, producing a profit of $100. Any questions on number 10? All right. That's the Chapter 7 review. Study that up. Hope you do well on the Chapter 7 test.